Alright, my name is Sean Niekamp, and this is my volcanology analog experiment. It's going to be between the Pahoehoe and the A'A lava flows. We're comparing and contrasting the different viscosities and how they act when flowing over a surface. I have my board here at a 45-degree angle to simulate the slope of a surface that these lavas might be flowing through. Before we get started, a couple things I want to point out is that these lavas come from effusive eruptions, which is a non-explosive eruption. It's nothing like Mount St. Helens. It's a passive flowing like you get in Hawaii. So, with that being said, Pahoehoe and A'A lavas are both basaltic, and when these lavas are hot, they have a very low to little yield strength, which means that the substances continue to be fluid no matter how quickly they're jarred or moved, and that's when they're hot. We see Pahoehoe lavas are generally 1200 to 1100 degrees Celsius, while A'A lavas tend to be about 100 degrees cooler on average. We see that what we're expecting is a lava flow size. In height, the A'A lava is about 10 times larger than the Pahoehoe lava flows. Pahoehoe lavas are generally tens of centimeters tall, while the A'A lavas can be tens of meters tall. This also goes with the speed of the lava. What I'd like to state before I start my experiment is that I will not be able to show the speed difference in the lavas. The speed difference is the A'A lava will travel and flow 10 times faster than the Pahoehoe, but I won't be able to model that in my procedure. So with that being said, what I'm going to be doing is I'm going to be pouring a mixture of pancake batter, 1.5 to 1 mix batter for the Pahoehoe, and a thicker mix, 2 to 1 for the A'A. The A'A also contains popcorn kernels to give it that sort of crust that we see with an A'A lava. It's called clinker. It's the cooled parts of the lava that have turned into basaltic rock. So we will pour the lava at this point 5 centimeters and let it flow down our surface over a 30-second period, and we're going to look and note what kind of shapes it forms as it pours down the surface and flows. And also, I set up little trees here to simulate objects in the way, and we're going to see how passively or aggressively the lava flows, both the Pahoehoe and the A'A lava, to see if it passively flows around the objects or if it's going to push over our objects and move through it. So, with that being said, I'll start with our Pahoehoe lava, and we'll do 2 trials, 30 seconds each. Here's a close-up view of our board and the surface. These are the little trees I've made out of toothpicks and paper, just stuck into the cardboard to simulate objects in the way of our lava flows. Located on the board are measuring marks running down the board to show how far the lava flows within the allotted 30-second time period. We're going to begin our first trial, 30 seconds, with the Pahoehoe lava. And as you can see, what we expected, the Pahoehoe lava is traveling down the ramp. And we are going to get a mark at 46 centimeters. Here is trial number 2 for Pahoehoe lava. And as you can see, it kind of has a ropey surface. That's what we see in Pahoehoe lavas. It's a little thinner, ropier. It actually creates a kind of a thin crust which the Pahoehoe will shoot out of into toes, that they call them. And as we're running down the surface again, this one's moving a little bit quicker. We're going to time it now, and we are at 49. Here is our A'A lava flow, first trial. I'm going to start the timer once the lava hits the surface. Okay. I'm going to mark it at 17. Here's our second trial for the A'A lava, and I'm start the timer when it hits the surface. As you can see, this is much more viscous. It travels in blobs. You can see the clinker within it as it's moving down the surface. We have a lot higher buildup as well than the Pahoehoe. Pahoehoe was thin and runny. This is bumpy and jagged. You can see how it would be hard to climb on it. And we're not getting much more movement from it. And we passed our time limit, so I'm going to mark it there. We're going to say she's at 15. So what I want you to notice here, if you can zoom in a little bit, come in, you can see how the clinker has caused a very jagged and rough surface. We see this a lot with the A'A lavas. It's very difficult if you're a hiker to climb over the top of this sort of thing, where if you move over here to the Pahoehoe, our Pahoehoes are very smooth. It gives a very smooth surface, ropey, and much gentler. So also, one thing I wanted to state, as you can see, these trees, I don't know if you can get a better angle on it, but some of these trees have been pushed over and deformed by our experiment. That's what you see with A'A lavas. It's going to bulldoze over objects in its way. While we look at the A'A lava, or the Pahoehoe, I'm sorry, we see that the trees were not affected, and we have some magma up higher on the trunk than the rest of the tree. This is what creates the lava tree features. Once the lava moves through the area, it leaves that crusted basaltic rock around the trunk, and the tree later dies. I'm going to finally touch just on a few of our results. As we see, the Pahoehoe ran much further than the A'A lava. It's been several minutes since the experiment has taken place, and the A'A lava hasn't gone very far. While in reality, the A'A lava would advance quicker than the Pahoehoe, A'A lava does not travel as far generally as Pahoehoes do. Pahoehoes, as they cool and stretch out, they can turn into A'A lava flows, but not the other way around. So I feel like this gave us some realistic results. Our Pahoehoes, we found a width of 3 centimeters in, or an average width of 3 centimeters of the flow. The height was 3 millimeters tall on both flows, and we were right around 47 millimeters for the length of the flow. When moving to our A'A lava flows, both times we saw the width of the flow about 7 centimeters, a height of 1.2 centimeters, which is about a little less than double, or 10 times, I'm sorry, a little less than 10 times the height of our Pahoehoe flow. And overall lengths ranging from around 15 to 17 centimeters. To conclude my experiment, we were looking at the differences between the Pahoehoe and the A'A lava flows. We looked at texture of the dried surfaces. We looked at viscosities of the magma or the lavas. We looked at the length, height, and width of the flows once the lavas began to run down the surfaces. If I were to do this experiment again, I would ask another person to be the sole timer for the experiment. I found it difficult to both time, pour, and accurately watch the lava flows as they move down during my experiment. So for more accurate data, I would incorporate more study participants. Besides that, I feel like it gave us a realistic look at the differences in the lava flows, and I really enjoyed doing it. Thanks, guys.